Parallel indexing is a navigation technique used by mariners to maintain a safe distance from a navigational hazard, or to ensure that the vessel stays on a desired track. This method involves using radar and electronic navigational charts, or paper charts to create reference lines, or index lines, parallel to the ship's course, to continuously monitor a vessel's track, to a predetermined passage plan. Parallel indexing, commonly known as PI, should be determined during the passage planning stage, whether you are using an electronic navigational chart or a paper chart. Assuming that this is our planned route, with a course of 319 degrees true. As per the set safety parameters in our ENC, we have non-navigable water on both sides of the planned track. We will use this island as our reference point to set the parallel index lines during our passage in this area, since this island is recognizable in the radar. We need a radar conspicuous object as a reference point to set our parallel index lines. When we say radar conspicuous objects, these objects provide strong radar echoes, making them prominent on radar displays. Examples of these objects are lighthouses, harbor walls, headlands, and large cliffs. Buoys and other floating objects cannot be used as reference points as they might drift away anytime. Shoreline with drying heights are not reliable as a reference point, because this might be above the water during the passage. The color green indicated in our charts is the shoreline with drying heights. These areas of the shore are exposed at low tide, but submerged at high tide, so this is not a reliable reference point for parallel indexing. The shoreline of this island has no drying heights, so here will be a good spot to set our parallel index line. The blue color you can see around the island, and on the other areas of this chart, is not a drying height. That blue color distinguishes the navigable and the non-navigable water based on the set safety contour in our ENC. I have made a video on how to determine and set the safety parameters in our ECDIS, kindly check the link in the description. Before we set our parallel index lines, first we need to mark our non-navigable water as no-go area. It will be done whether we are using an ENC or paper charts during the stage of passage planning. Next, create a line along the selected reference point. The line should be parallel to the planned track. This is how we do it using a paper chart. But if you are using an electronic chart, use the PI tools provided in your ECDIS. This is now our parallel index line. Measure the distance from the planned track to the parallel index line, that is your PI distance, in which in this chart, 1.70 nautical miles. Before I will discuss the not less than or NLT, and the not more than or NMT lines, let us set this parallel index line first to the radar. Upon approaching the island, we need to set the parallel index line to our radar. The radar interface that appears on your screen is an image from a radar simulator. It is set to relative motion, with north up. The ship's GPS heading is 319 degrees. The island provides strong radar echoes, making it an ideal spot to set our parallel index lines. We will use the PI tools provided in this equipment to set our parallel index line, starting with PI 1. For the heading, this is the direction of the PI lines, which is the same as the planned track, 319 degrees true. For the distance, it is the parallel distance from the planned track, and the set parallel index line, which is 1.70 nautical miles. For the side, it is the side to where a conspicuous object is located from the planned track. In this case it is located on the starboard side of the planned track. We have already set our parallel index line. We can also use the electronic bearing line known as EBL, and the variable range marker or VRM to set the PI line. Since the radar is set to relative motion, all stationary objects will appear to move in reciprocal direction of the ship's heading. If the selected reference point is along the parallel index line as it moves in a reciprocal direction to ship's course, it means that the ship stays within the planned track as she moves in her intended course. As we know, GPS is subject to some interferences, thus giving us position inaccuracy. This navigation technique is very useful to navigator as it gives a continuous monitoring of the ship's position along the intended track. Even though this technique is used, regular intervals of fixing the ship's position should always be done as stated in the passage plan. However, knowing that the ship's position is in the planned track, this is not the only objective of the parallel indexing technique. Knowing that the ship is still on safe water even if she is not along the planned track is the primary objective of this navigation technique. In this animation, you can see that the reference point is not along the PI line, it moves towards the ship. It means that the ship moves towards the island, so she is off track to starboard. A port helm should be executed until the reference point is along the PI line. As it goes back along the PI line, the ship's position is also along the planned track. On the other hand, as the reference point moves away from the PI line, the ship is off track to port. Executing a starboard helm will bring the ship to its planned track. If we look at our ECDIS screen, the ship's position is still in safe water. But how are we sure that it is the actual position of the vessel, since our ECDIS is integrated into our GPS? As we know, GPS may be subject to position error by a few or several meters due to environmental and atmospheric interferences. The possible actual position of the ship may be here, or she might be crossing the no-go area. To determine whether the ship is still in safe water even if she is off track, we need to set the not less than, and the not more than PI lines in the radar. To do this, in your paper chart or electronic navigational chart, determine the distance of the navigable water on both sides of the planned track. Draw a line along the no-go area parallel to the planned track. It should be done on both sides. Then measure the distance from the planned track. In this chart, the room for safe water on the starboard side of the planned track is 0.80 nautical mile, and on the port side, 0.95 nautical mile. This is now the corridor for the navigable water as the ship passes along this area. To determine the not less than or NLT line, we need this parallel distance. So NLT is equal to PI distance minus the safe water distance from the planned track towards the selected reference point. The PI distance is 1.70 minus the starboard safe water distance, which is 0.80. The not less than PI line is 0.90 nautical mile. To find the not more than or NMT line, NMT is equal to PI distance plus the safe water distance from the planned track away from the selected reference point. So PI distance is 1.70 plus the safe water distance on the port side, which is 0.95. The not more than PI line is 2.65 nautical miles. Always remember that the not less than PI line distance should be measured on the side of the planned track, where the reference point is located. And the not more than PI line distance is measured from the reference point towards the safe water on the other side of the planned track. You can also use your cross-track distance to determine the not less than, and not more than PI lines. Assuming that the cross-track distance on both sides of the planned track is 0.25 nautical mile. The not less than PI distance is 1.45 nautical miles, and the not more than PI distance is 1.95 nautical miles. In this video, I did not use the cross-track distance as the basis to determine the not less than, and the not more than PI lines, since the objectives of the parallel indexing technique are not just to ensure that the vessel stays on a desired track, but also to maintain a safe distance from a navigational hazard. This animation shows that during the risk of collision, even if you go beyond the cross-track distance, there is still enough navigable water to avoid such risk. It is your preference to use the cross-track distance as the basis to establish your not less than, and not more than PI lines. Let us set those PI lines in the radar. For the not less than PI line, we will set it along the PI2. All PI lines have the same heading as the planned track, which is 319 degrees. The NLT distance is 0.90 nautical mile. And the location of our reference point is on the starboard side of the planned track. The not less than PI line is already displayed. Let us set the not more than line in PI3. The heading is 319 degrees. The distance is 2.65 nautical miles. And the side is starboard side, since the location of the reference point is on the starboard side of the planned track. The not more than PI line is already displayed in the radar screen. The distance set in the radar is based on approximation. Since this is just an animation, I am not using the actual radar. Do not be confused about the set PI line on the radar, and the drawn lines on both sides of the planned track. Those lines are drawn in order to establish the not less than and not more than PI lines. If you want to set the PI lines in your ECDIS, it should be the same as the set PI lines in the radar. Let us take out this PI line along the reference point. When the ship is going to starboard from the planned track, the reference point moves closer to not less than PI line. And when the ship is going to port from the intended track, the reference point moves closer to not more than PI line. As long as the reference point stays inside the not less than and the not more than lines, the ship is within the navigable water. Let us animate it again, showing the ship movement in the chart. The object in the radar moves in a reciprocal direction of the ship's movement, and as long as the reference point stays within the not less than and the not more than PI lines, the ship stays with the navigable water. That's all for now. I hope you find this video helpful. Thank you for watching. Bye.